Hey everybody, welcome to this workshop where we're going to be going over Web3 for web developers. I'll start off by introducing myself. I'm Austin Baggio. I'm a product manager here at Pagoda, the team that builds Near, builds the protocol and all of the tools. And I'm joined with Ben, who you'll hear from a little bit later. And today, and before we get started, I'd just like to draw everyone's attention to this QR code in this link where you'll have access to the slides, all of the repos that we're going to be going through, examples, getting started, our help on Discord, and all that fun stuff. So go ahead and scan that. But what we're going to be covering today is just a really brief overview of what is Near, why you would potentially want to use it, and some of the developer resources. And then as well, we're going to jump into Near and JavaScript and how we've built a JavaScript suite in order to make it as easy as possible for developers to get started building on Near. And then Ben's going to take it away and we're going to do a live coding session where we're going to dive into a couple of examples, build an application, and go through the super quick create Near app getting started flow. So what is Near? Near is a layer 1 proof of stake blockchain. It's a dynamically sharded proof of stake blockchain. And the major focus is on scalability, obviously, with sharding and usability. We really never want to compromise on decentralization. We've just launched chunk-only validators, which helps massively increase the decentralization of the protocol. And something we always love to talk about is that we're completely carbon neutral. Why you'd want to build on Near: super fast transactions, incredibly low fees, and built right into the protocol for all the smart contract developers out there is a 30% gas fee royalty. So it's built completely into the protocol. You don't have to do anything. So the success of your application really helps to actually generate some revenue for you. And for the Ethereum audience, we are EVM compatible with Aurora, and you can get assets across using our Rainbow Bridge. So we also have a massive suite of developer tools. We have documentation that we've just recently updated. We have examples. We have our Discord where engineers like Ben and the teams that actually built the SDKs and the tools and everything are in answering questions regularly. We also have our YouTube where we have whiteboard series and we have deep dives into other contracts and examples, and we have our community updates. So you can check those out. And if you'd like a more guided experience, you can head over to the Near Certified Developer course that's run by the Near Foundation, where there's actually instructors or there's self-guided, and it'll help step through and go from 0 all the way through to a Near Certified Developer. So super quickly, a lot of people know JavaScript. It's about 20 million people that know JavaScript. And currently, a lot of the layer 1 blockchains are using Solidity or Rust, and that's about 2.5 million developers. So opening up to JavaScript really makes a lot of people Web3 developers. And that's because we've just recently introduced the Near JavaScript SDK, and it's part of the Near toolkit in order to build smart contracts and blockchain applications on Near. So what does this actually mean in practice? One of the things that we love so much about building our JavaScript applications is that we can just install packages via NPM. And the JavaScript SDK is no different. It's a simple install via NPM. You can interact with the contracts using our CLI. You can build and deploy with our CLI, and you can literally write the contracts in JavaScript or in TypeScript, and you can test it with our Workspaces framework, which is a testing framework that's also there's also a JavaScript implementation of. So the entire scope of your application can all be written in JavaScript. Great. So just one last opportunity. I just thought I'd flash this QR code before I pass it over to Ben, who's going to take us through a live coding example. So Ben, I'll pass it over to you.
Thanks so much for that, Austin. Hey, everybody. My name's Ben Kurek. I'm developer relations here at Pagoda. And today we're going to be going through some live coding for some JavaScript smart contracts. So the very first thing that we're going to do is we're going to look at a super basic status message smart contract where you can store, retrieve, and change a status message on chain. At that point, when that's finished, we're going to go ahead and we're going to code a simple smart contract from scratch. It's a coin flipping example where you can pass in either heads or tails, and the contract will keep track of how many points each player has. At that point, then we're going to go ahead and we're going to deploy it, and we're going to actually interact with it with a front end. And then once all of that is finished, I'm going to teach you how you can build a dApp in under 30 seconds with Create Near App. So let's get started. I'm going to go ahead and I'm going to share my screen. Austin, let me know when you can see this.
Perfect.
Awesome. So I'm over here at the JS SDK workshop links, and what we're going to go through is actually this workshop example project. So this is the repo that we're going to be working off of. If you're following along at home, there's two things that you can do. One is we've got a Git pod link here, so you can open it up in the browser and you can interact and follow along from there. Or you can clone the repository and do everything locally. In this case, I'm going to go ahead and I'm going to clone the repo, and that's how we're going to go through the example here. So in my terminal, I'm going to run a git clone on this. Then I'm going to cd into the directory. After that, I'm going to open it up in VS Code, and we're going to look at the project structure here. So there's a couple things to note. First off, we've got a front-end folder. This is where all of our front-end code will live. React app is super basic, super simple, and it has our connection to the near blockchain, where I'll talk a little bit more about that later. And then we've got the source folder. This houses the actual code for our smart contract. We've got a package.json, which is where we'll have the dependency, and this is how you can actually interact with and get started. All you need in this file is the near SDK JS package here. Let's go and let's open that source folder and let's look at the contract. The first thing that you'll note here is that it's written in TypeScript. Now, you can either write this in TypeScript or you can write it in JavaScript. It doesn't matter. At the end of the day, the SDK will compile everything down into JavaScript and then finally to WASM. So it doesn't really matter. Me personally, I like TypeScript so that, when you're writing smart contracts, obviously you don't want to be running into any bugs. And so TypeScript just helps me have that one extra layer of a sanity check. But that's that. So let's look at the contract here. At first glance, it looks eerily familiar to any other class that you've seen before when writing regular TypeScript or JavaScript code. You've got a constructor, you've got some methods, right? It's a class. It's pretty simple. Now, the only thing that's different is we've got some imports here. And those are coming from the SDK itself. So what do they do? The very first thing that we have is this nearby and decorator. You can think of that essentially as the glue that allows all of the code to interact with the runtime. It's a little bit of magic behind the scenes, but all you need to know is you need to put that decorator here and everything will work smoothly. And then we've got this near contract parent class. This essentially just allows it to fit in the correct format such that it can be compiled down to WebAssembly. And then we've got some call and view decorators. What do these do? So you'll notice here we've got two methods, set greeting and view greeting. You could think of the view decorator as a getter, and you can think of the call decorator as a setter. The call decorator allows you to change the state on chain, and the view decorator allows you to query for that information or for any information from on chain at no cost. So what is this doing? We've got this field in our contract, my greeting. It's of type string. The constructor will essentially just default this field to a default message. In this case, we've got hello Web3 world. And then we can view the current greeting, which returns a string, return this.myGreeting. And then we've got a setter where you pass in a message that's of type string, and it sets this.myGreeting equal to that message. So let's get started. The very first thing that we're going to need to do is we're going to need to install all of the dependencies. So let's run an npm install, which will download all of the dependencies, including the SDK that we're using for the smart contract. And once that's done, we're actually going to go ahead and we're going to build the contract. So we'll just wait for this to finish. And here we have it. So now let's run the build command. So we'll do an npm run build contract. If we open up the package.json, we'll see what that does. All it's doing is just running the near SDK.js and build command, and it's pointing it to our contract file. What this will do behind the scenes is it'll create a build folder here, and it'll put the WASM into that folder. So once it's done, here it's done, we have the contract.wasm. This is the file that we're actually going to go ahead and deploy to the blockchain. So let's go ahead and let's do that now. There's two ways that you can go about deploying a contract on chain. One way is you could go to wallet.testnet.near.org. You could create the account, and then you can log into your local machine with that account. Or what you can do, which is often more used when developing, is you can run what's called a dev deploy. This allows you to bypass that account creation process where you can quickly deploy to an account that's created on the fly. It's known as a dev account. So we'll do that here. We'll do a near dev deploy, and then we'll pass in the path to our contract. And so what this is doing is it's creating an account and deploying to it all at the same time, just so that you don't have to go through that account creation process. And you'll see here that the account ID is this dev-16603. It's essentially, that's the account ID of the dev account. And if we open up the Explorer, this is a handy dandy tool that a lot of developers use to look at, the status of a transaction and the execution plan. So here we see that the status is successful and that the contract was deployed. Great. So now we have the contract on chain, and let's go ahead and let's run the initialization function. So for ease of development, I may or may not have gotten rid of the dev account here, but we can get it from here. So for ease of development, rather than having to copy and paste that dev account every single time we run any functions, let's just export an environment variable. So we'll run export JS contract, and we'll set it equal to our dev account. From there, we'll call the init function, near call JS contract, and then we'll do init, and we'll sign it with that dev account itself. So if you remember, that initialization function will set the default message on the contract. So if we look at the Explorer here, it was successful, and we called the method init. Great. So now if we go ahead and we go to our contract, and we view the greeting, it should return hello Web3 world, because that was the default message that was populated in the constructor. So we'll do a near view, and then we'll do JS contract. We'll do a view greeting. And here we go. Hello Web3 world. Amazing. So we deployed the contract, and we called the init function, and now we got that default message there. So let's go ahead now, and we'll actually change it. So we'll run a near call on the JS contract, and we'll do a set greeting. In this case, we'll pass in that the message is go team, and we'll sign the transaction as that dev account. So once again, if we open up the Explorer, we'll see that it was successful and that we passed in that message and called the method setGreeting in this contract. Now, if we go ahead and we query for that state again, it should be go team. And there we have it. Awesome. So now what we have is we have a contract. It's been deployed. We've interacted with it using the near CLI, and the contract was fairly straightforward. So at this point, what we're going to do is we're going to go ahead and we're going to code our own contract from scratch. So if you're following along, you can do a git checkout on the skeleton branch. So here we see that it's a new contract, but everything hasn't been filled in yet, and it's up to you to do that. So what is this contract? This contract is a coin flipping contract where the user can pass in a side, and they can call the method flip coin. That side is either heads or tails. If they get it right, the contract keeps track of this points field, which is essentially just a mapping of an account ID to a number of points that they have. If they got it right, we'll increment their points. And if they got it wrong, we'll decrement their points. We've included a super simple random number generator function here that returns either true or false. And that's how we know what outcome actually happened. And then finally, we've just got this getter here, viewpoints, where you can pass in the player, and it returns the amount of points that player has. So let's get started. So the first thing that we're going to want to do is we're going to code the viewpoints function. So what does this do? We pass in the player. So the very first thing that we're going to want to do is just check if they don't exist, or actually we'll check if they do exist. So we'll do this dot points has own property at the player. So if they do exist, what we're going to do is we're going to return this dot points at the player. If they don't exist, we'll just return null. There we have it. So that's a super simple function. The logic is fairly straightforward, but this allows us to query how many points someone has. Now what we're going to do is we're going to code that flip coin function. So there's one more thing that we've introduced or imported from the near SDK JS. Everything else is the same. We've got the near contract, near bind, the call decorator, the view decorator, but now we've got this near object. What does this do? Oftentimes when you're doing development or in the runtime of your contract, there's a lot of information that you might need in your contract. For example, who called the function? How much near did they attach? Something like that. So we'll use this object to our advantage to get the person who called this function. So let's do it. We'll do a let player is equal to near.predecessor account ID. This is essentially just who called the function. And then we'll check if that player exists yet. So we'll do if they don't exist. So if not this dot points has own property at the player. So if they don't exist, all we're going to do is set them to 0. Okay? And then what we're going to do is we're going to log. Logging is often really, really important for debugging or for just getting important information that you can view in the Explorer. And again, that comes from that near object. So we'll do a near.log. In this case, we'll say the player chose the side. And then what we're going to do is we're going to get the random number. So we'll use that generate random number function to our advantage, and we'll say let random number is equal to generate random number. This is either true or false. Because we're writing the smart contract, we have full authority over what this means. So in this case, what we'll do is we'll set false to heads and true to tails. So we'll say let outcome is equal to if the random number is equal to false, then we'll do heads. But if it's not, we'll do tails. Now we have the outcome and we have the side that they chose. So what we'll do is we'll do if the side is equal to the outcome, then we'll do this dot points at the player, we'll do plus equals 1. And then what we're going to do is we're going to log again. So we'll say this player got a point, right? Now what we're going to do is else we'll do this dot points at the player. In this case, let's set it so that if they're at 0 already, they can't lose any more points because that's just demoralizing. So we'll say if this dot points at the player is equal to 0, then we'll just set them equal to 0 and we'll keep them there. But else we'll subtract 1 from their points. And then we'll do near.log, you lost a point. Amazing. So that's the flipping coin function. It's super simple, and we use that generate random number function. So now what we're going to do is we're going to go ahead and we're going to build and deploy. Now, we've written a super simple script that you can use, so you don't have to run that dev deploy. You don't have to initialize or anything like that. All you can do is run that npm run deploy. So we'll do npm run deploy. So what this will do is it'll build the contract, it'll do a dev deploy, and then it'll also call that initialization function all for us. So we don't have to keep writing that in the terminal here. So here you can see that it's building the contract. It's deploying, so it's starting that deployment, in this case on dev-16603. Call the init function, and then we should be good to go. And there we have it. So once again, let's copy this dev account and we'll export it to an environment variable just for ease of development. So we'll do export JS contract. It's this contract here. And then what we're going to do, let's call the viewpoints function. So we'll do near view on the contract, and we'll do viewpoints. In this case, we'll pass in the player as the current contract. In this case, it should return null because that player doesn't exist yet. And there we have it. Everything's good to go. So now let's go ahead and let's actually flip a coin. So to do that, we'll do a near call on the JS contract, and we'll do flip coin. In this case, let's call the side as tails for now, and we'll sign it under that dev account. So it's doing the function call, and you'll see here our logs. So it said the contract chose tails, and we lost a point. Unfortunate. So now if we view our points again, it should be 0. And there we go. We've got 0 points. We didn't go negative because we didn't want to do that. So let's go ahead and let's flip a coin again. We lost a point. Luck is not on my side today. Let's go again. There we go. We got a point. Now if we view our points again, you'll see here that we got 1 point. Because all those other times, we just defaulted it to 0 because we didn't want it to go negative. But now this is the first time we've won a point, so now we have 1 point. And there we have it. That's our contract. We deployed it, we built it, we interacted with it on chain, but we interacted with it using the near CLI. So now what we're going to do is we're actually going to go ahead and we're going to use the front end to do this. So let's go. Let's run an npm run start. which will build the contract, it'll deploy, it'll init, and then it'll spin up a quick front end. So while that's building, let's go ahead and let's actually talk about the contract or the front end code itself. So in this folder, everything is a super basic React app that you've seen before, right? You've got your index.js, you've got like your HTML, you've got your app where we've got some state. It's essentially just a super simple React app. But what's different now is we've got this one file here called near API. What this is doing is it's using the library near API.js to establish a connection with the near blockchain. From there, it has that wallet connection, and you can do things like sign in, sign out. You can view blockchain state. You can call smart contracts. So you can do all of this that we've defined here in these functions, and you can use that in your app. So while this is building, hopefully it's almost done. Here you can see it's just doing that initialization function. Actually, while that's going, let's create a wallet here. But this is the front end. Let's sign out and let's go ahead and let's create a new near wallet. So we'll go to wallet.testnet.near.org. We'll create an account. In this case, we could say JS workshop testing, for example. So we'll reserve the account ID. We'll get the passphrase. In this case, everyone watching, you feel free to take the seed phrase here. It doesn't matter. This is all fake money, but yeah, this is our account that we're creating, and then we'll get some testnet money here when it's done, and we'll be rich. There we go. We got $1,000, and then let's sign into that account that we just created. So JS workshop testing, and we'll connect to our dApp. There we have it. So my points. How is it getting this? Again, if we go to that near API, we can look at this function here, view blockchain state. So what it does is it gets the wallet connection, gets the account object, and then what it's going to do is it's going to do a view function similar to what we did in the CLI, where you pass in the contract, you pass in the method, in this case, viewpoints, and then as the args, we're saying that the player is the current wallet connection's account ID. And that's how it's getting that state. Now, what happens if we choose heads or tails? In this case, we didn't have a ton of luck on tails, so let's go heads for now. So while that's going behind the scenes, what it's doing is it's calling this function call smart contract function. It passes the message, and here you can see we've got a log, message args. We've passed in heads, and what it's doing is it's getting that account object similar to that view state function, but this time instead of doing account.view function, it does account.function call. In this case, again, you pass in the contract, you pass in the method, and then the args is exactly what we want to pass. So the side as the message args, and then we attach some gas. So we go back here, we'll see we chose heads, and we got a point. So there we go. Now we've got 1 point. Now let's go heads maybe again, because luck seems to be on my side. And there we go. We got another point. That's great. So that's a super simple front end that is interacting with a JavaScript smart contract that we deployed to the blockchain. And that's about it. So if you want to get started, there's this super simple handy dandy command that you can run. So we'll cd out of here. And it's called create near app. So if you have npx, what you can do is you can do an npx create near app, just like this. And you can select your smart contract language, either JavaScript, Rust, or AssemblyScript. In this case, we'll do JavaScript. You can select a template, right? So either React or vanilla JavaScript, or maybe even just no front end. In this case, maybe we'll do React. And then you can give it a name. In this case, we'll say JS workshop testing or something like that. And then you can either install the dependencies or not. In this case, we'll do no. And I've already run this command behind the scenes and installed all of the dependencies. So we'll cd into that directory with all of the dependencies installed. And then let's open it up with VS Code. So this is what's generated from that command. Again, you've got the contract, you've got the front end. Everything is fairly similar, where you've got the actual TypeScript contract. It's a similar concept from the example we just went through. It's a greeting function or contract. And then we've got the front end with the app.js. We've got that near API file here with sign in, sign out, set greeting, get greeting. It's fairly similar to what we've done. And then all you need to do to actually get started is run an npm run deploy, which will deploy the contract, build it and everything. And then once that's done, which is the same command that we've been running up to this point, then all you need to do is run an npm run start, and it'll deploy the contract or deploy the front end for you. So I'm not going to go through and do that right now, but that's just how you get started in under 30 seconds to create your own decentralized application. So yeah, that's it for me, and I'll pass it on to Austin.
Awesome. I'll just wrap this up quickly. Thanks, Ben, for showing us all that and going through a live example. Hopefully, we were able to communicate how easy it is to get started using the new JavaScript SDK. And really, the reason why we're doing this is so that you can spend less time learning new languages and more time building your apps. So you can find us on Discord. Again, that the link that we had shared earlier that has the workshop resources, is the best place to just find all the content you need to get started. Otherwise, reach straight out to us, and happy hacking. Thanks again.
Thank you, everybody.